Så det är ganska...
Vad är det för mitigation då? Alltså, om du kommer in på en båt, vad är det för mitigation för att inte ta sig upp och in?
Inte kunna prata med mig, inte kunna prata.
Nej, alls? Okay. Kan du liksom tejpla bort?
Nej, du har alltså GKI har shielded notes. Då är det löst. Då är de i en annan box. Då kan man inte göra det. Sen kan du ha privileged points only.
Okay, så det är verkligen flaggor liksom.
My question with this has always been, why didn't they build the fabric on the back end a little bit more restricted?
Because of portability and change, like look at the commits on communities over 1 year. How many lines of code that they just gets thrown in the bin and then something else replaces it, which is basically the problem here, because no one really knows what's going on. And it's like with objective programming when it goes bad. So it's a good thing, but it's also a bad thing because everything sort of needs to be able to talk, you know.
Probably should have you can have like a control that it's allowed to do whatever you do.
And they sort of shifted to that in order to be like more SLAs and sort of having a handle within the code connected to an actual thing, which is a lot more safer because then you don't have to provision keys and login stuff to do. Then you have like one notification schema that is integrity valid and it's like 1 point of what it is. It's like it's very simple. And that's like I could go on forever with this because this is like another thing that happens all the time is the cluster binding rules and customer permission rules. There's like an inherited thing that is adopted to the REM model, which is insane because Google in this case, because that's been well done lately. They have a provisioning schema for a bunch of services, even though you're not using them, you get permission by well. So then you can sort of leverage that in order to get access to stuff that you shouldn't be able to.
So they are like opt-out only, like can you disable that? Okay, you can't. So it's just there.
But if there is nothing on the other end, then you can't do anything. But let's say you just play around with it and you have something, then that's reachable by
So in my limited knowledge of containers and this sort of thing, because I've been playing with it a bit, I still am scratching my head about it. Has anybody gotten into like SE Linux?
Yeah, well, there is a lot of like armor, like up armor and SE Linux, and there's a lot of good initiatives. We have something called.
You would think that that would make total sense for containers.
So insane. So what I do is like I work with a bunch of guys that hack stuff, and we got a good rep, so we get to hack a lot of stuff. So I do have all the conditions for all Cloud Native Computing Foundation stuff that is going to get included in the Linux Foundation. So then I get to see a lot of shenanigans. So there is one project now that is not really, it's not this container. It's basically a secure subset of texts that you apply to your container. So it is like, it has a YAML file that is hard to identify. So if you take their node example, that's basically, or it's like, it has all this stuff incorporated in it in order to be more secure. And then it has like a UI for S mode, and you can see how it affects it.
Even if you had something that's a code, deployment is code for something like Azure, it would be spectacular to just say, okay, here's a file that has the thing that is all deployed, and here's where you can take and say, here's the coordination of this to check someone, everything deployed, and if anything changes.
The only, like, I would say, AWS and but Azure I haven't talked that much, but the things that I have talked about, they have like, they have been totally shit in terms of Kubernetes, like the worst thing ever possible. So they have
the blog posts with people like it's way.
There is a semi-public thing that me and the guy made for a site for a project that works on that. Read that one. Holy shit. It's terrible. So that's like, they don't really know what they're doing.
Yeah, but this is the barrier between, okay, we have a whole bunch of people doing a shitload of development and running fast, versus we have a whole bunch of people running fast with security
might be different reasons, but it's like the same thing applies to like all these humongous companies. Often the security team is also much much smaller than the teams are. Oh yeah, yeah, yeah. No, exactly. You don't need a. You just where we can have them do both things. Both the
Rire et chanson. Rire et chanson.
Yeah, it's like we talked about this with the fellow CEST, and she's like from the old school, Java, old school. And she's like she's 47 or something, so she's big. She works at Clarence, like the old shit. And Marissa, I know she's like tech lead-ish, like more of an adult, not still young. But she looks at commits now and she's like, I'm so angry with what it has become. Like objective programming is like not a thing anymore. It's just we don't think about the whole picture. Like coding is really going to shit, and that is not really good. Like the sort of pipeline of this full stack whatever, it's such a weird ass acronym to have because that means that you're narrow. You have like one path to this sort of end of your rainbow, and it's so many layers of shit that goes on that you have to know, and especially in the cloud realm, and especially with orchestration, and then you should have a replica system. Because like with the report that you have a server and you have a web application on it, and now it's like gazillion billion things in it just to accept everything.
house. If you have a guy that do the electricity, the water, and also feeds the house, like you might cut some corners on the quality. And it's like no shit,
No,
no shit. Or maybe they have like a open API schema, but it's outdated as fuck, so it's like it doesn't even correlate. Exactly, so you show up. Yeah. it's like, why did nobody ever do this in terms of security?
Evidence system.
But so they did a great job for the process to get all the data out, but that kind of work was never done like security wise to get like what type of exposure do we have in terms of third party.
Hello.
Hello, everyone, and welcome to this new CEST experiment. We're very happy that we have anyone here because we're really good at security and conferences. We're not really that great at communication. So we just moved this community event because the conference is getting bigger and bigger. So welcome to the first edition of the CEST Community Day event, which is actually the 6th community event that we're running with the conference. And the history of this event started with, we have so much rigging to do, to get the live streams done, to get everything on track, and a lot of rigging. So we rented the venue the night before, and then if we were done rigging, we could already start having events. But now since we're already paying for it the whole day, why not start the events earlier, especially now since the tickets have been sold out for like at least 2 months. So we want to be able to still grow the conference a bit and open it up to more people and to the community and do a free day. So we had no idea how many people are coming. So we're going to try to do an estimate about how many people are here. But yeah, I'm glad to see so many because we haven't really communicated this in a really good way. Well, CEST as a conference started in 2008 with me and some of the other founders. We were flying back and forth to Black Hat because that's where all the cool talks were. In Sweden, we had nothing. So then we started, me and Matthias and some people at my current company, saying like, why don't we just invite the speakers here so we don't have to go to the US every summer? It's too warm in Vegas. I'm getting too old for this. And basically, that didn't work out, so we lost a lot of money. Airfares was expensive, people had to have food. But yeah, basically we started to do break even in 2011, and then we actually started paying our speakers. So we are still one of the very few conferences, except for Black Hat, that actually pay our speakers. So this is basically the conference that we would like to see. So we, in the CFP group, we do get a lot of CSPs, and we're selecting the content that we as nerdy hackers would like to see. And yeah, we started the community night, as I said, in 2016 because we already had the venue. And then we started trainings in 2017. And they're also like sold out months in advance. We should be able to do much more trainings. And that's something that we get a lot from our attendees, that they really enjoy the trainings. Unfortunately, though, we as organizers can't really go to the trainings, but we pick the trainings that we would like to see and bring them to the community. So I really want to go to all the trainings, but I haven't been to a single one, of course. So yeah, and then, so that's growing. And now the community event 2023, and you're all here. So yeah.
Yeah, so the community night has been, according to us, a huge success. We wanted to invite more and more people to attend our view of what a security conference should be. But as Thomas said, we've been paying for the venue anyway, so we started having the event during the night. But at the same time, we're trying to have a speaker dinner where we try to actually hang out with our speakers. But that meant that some speakers had to run back and forth between the dinner and the stage. That doesn't really make for a nice, pleasant experience. And some of us organizers also had to run back and forth. I've been on the stage for the community night before, and at the same time, I'm the hostess for the dinner that's way over there. Really complicated, lots of running. So we wanted to either change the community night or the speaker dinner, but the problem is the speakers, they aren't really here that early. I mean, most of them fly in on the Wednesday, and they won't be here until somewhere Wednesday afternoon. So we thought, let's open this event up for more people and just move the community event to the day. We also generally get a good bunch of submissions for the talks to CEST, and we want to be able to accept more speakers for longer time slots. The community event in the evenings was great, but as you know, the evening grew longer, people had more and more to drink, and after a while, they weren't really listening that much. You guys are great, but not, you know, beer versus talks. Doesn't always pan out as it should. So this way, I think more people will hear better quality talks with better quality audience.
Yes. However, the bar is open, so you can order a drink. It's not like you cannot drink and listen to talks. That you definitely can. But yeah, we think this is a better solution, and we like your feedback if you like this, how you like this way. But yeah, that's our thinking behind Community Night becoming a day, and we also have backup speakers that are presenting here that could present at the big conference. And luckily for us, because we have so many great submissions, this has enabled us to actually accept more talks, and also trying some new talents on Community Day that maybe didn't make the cut for the full conference. And also, we like to get even more submissions next year, so this is a way to also open up this type of conference content to new audience that maybe they can't afford the CEST tickets, and do that. And please submit. We like to have more Swedish submissions than we have, and we like to have more quality submissions in general. We are same size-ish as last year on the main conference, and we know that because we cannot squeeze any more people into the venue. So we have already sold out.
However, we don't know how many we're going to be today. We have estimates going between somewhere around 25 and 2,500. So, I mean, I'm very glad you're all here.
So yeah, how many people do we estimate is here? Let me count. 1, 2, 3. No, but I think we are about 250 people in the room. I've been counting you while she was talking, which is good, but spread the word that CEST nowadays are going to start earlier. So if people want to come earlier, be here earlier.
Yes, and we're going to have 5 talks. We will be open to lightning talks both today, I think, and tomorrow. So if you have something that you'd like to talk about, drop us an email. You'll find all the details on the website, and we'd be glad to hear from you. There's no sponsors to the specific community event. That's our gift to you. There are, however, sponsors to the main event, but they haven't had the time to actually set anything up yet. They're doing it as we speak, I hope.
And yeah, we're going to have 5 talks, and we're going to have like 50-ish minutes between the talks, and the talks are variable length. So this is a more open-ended, so some people I know are going to have longer talks, some are going to have shorter talks, and in between the talks it's up to you to mingle, have a beer, have fun. The bar is going to be open, there is not going to be any drink tickets, and you can also, if you get hungry, there's a sausage cart there we can order hot dogs from. So that's the entertainment that we have, but yeah, that is the plan. And who we are still running this as very much as a non-profit. And we're not only a not-for-profit organization, none of us actually pay ourselves anything for doing this. I mean, most of us have well-paid jobs, so it's not like we're starving, but we're doing this for the community, and we're not taking any payment. And everyone's doing what they want, says on the slide. That's not really true. Sometimes you have to do stuff that you don't like. But in general, we are a very open community, and we have the stream team that are sitting there. There are now 6 or 7 people making sure that everything is streamed. And we are, economy-wise, we are splitting the cost of the event between 50% sponsor money and 50% tickets from the attendees. That's our aim. And yeah, our sponsor revenue has increased, but so has the number of people attending. So we still think we're on a good level there. So we are now a whole bunch of organizers, as you can see. And we also have a CTF team that is doing Capture the Flag, which is going to open tomorrow. We also have a club that's been ongoing, that's also open for everyone tomorrow night. And then we have Säkerhetspodcasten here, which is doing like interviews with all the speakers and making that content. So as you can see, we've grown quite a bit. We're quite a few organizers now, which is really nice since we're a non-profit and none gets paid, so no one has to work themselves to death doing this. But also, we are still interested. So if you're interested in being a part of the organizers, just reach out to us at info@cect.org and say, hey, I want to be a part of this. I can help out with whatever, or this is my skill. Is this something you need help with? We're always looking for more volunteers to help us out.
And if you don't really know what you want to do, but just know that you'll want to help out, we can probably figure something out.
Also, the stream, is it up? Stream team? Stream is up. So yeah, we now have a YouTube stream of this at youtube.com/sectdirector, which is our account there. And also, we are looking for lightning talks. We have a yearly program point, which is the lightning talks. And lightning talks are 5 to 10 minutes talks, which can be like not the finished nice presentation that would be accepted for Black Hat, but it can be anything. You don't even have to have the slides. You can say, hey, I want to give a lightning talk, and email to cfp@cect.org and say, hey, I hacked this thingamajig and I want to do a lightning talk. And those presentations are actually really fun. So we're still looking for more lightning talks for tomorrow. Oh yeah, this. We have to mention this. This is the venue. Where you came in is the same way you go out. The emergency exits are that way, to the right, and down where you came in. Because, yeah, that's something you have to tell people how to get out of the building. So we are here, where it says stage, currently, and we have marked the bar. Those are the two most important stuff on the map so far. So any questions? Yeah, this is online as well.
The map will be more complicated tomorrow, where we introduce food into this equation.
Yeah, tonight this is for dummies, map for dummies. You are here, stage and bar. So the schedule today is we're going to start off with Jesper Larsson. Straight after this, I can't see Jesper though. You might
I can. He's
okay,
here.
he's waving there. He's there. Cool. And as I said, it's going to be about 50 minutes between each talk. And if there is time slots between the talks, go have a drink, mingle, have fun, and enjoy the conference. So without further ado, Jesper, welcome on stage.
Let's do it. Cool. Is this on? It is on. Awesome. Thank you. Let's see if this works. So I'm running Linux and NVIDIA drivers. It will be fun for everyone. Let's see. We actually tried it out before, so hopefully it works. Otherwise, it doesn't. And we will compile drivers for an hour. It will be awesome. Let's see. Oh shit! I'm just kidding. All is good. Okay. Let's open this one up. You can't see anything yet. Hopefully this will work pretty good. So, oof. Pretty cool if I do say so myself. And this is the last slide, which you're not supposed to see yet. Let's do this. It's just a few slides, eh? A lot of slides, so it will be like a burst of things. So let's do this. This is mine, not for you to see. And then we should be able to get this in like a full screen. Hi everyone, I'm back. So today we're going to talk about some shenanigans that I found during my work as a penetration tester. It will be, the whole idea of this talk, I have to say before we start, was that I was supposed to present a really cool attack chain in authentication provider that uses authentication for banks. The banks buy this SaaS service and get sort of a template for authentication. And yeah, they use that and you install that in your environment and all kinds of shit goes down. Full cluster breakout. But then I started to investigate all the coding examples for the actual exploits. And if you have a little bit of Google Foo, you would be able to determine that company pretty fast. So I shifted the post-exploitation phase a little bit. But so who am I? My name is Jesper. I'm a freelance penetration tester. I work with offensive security for a German hacker community called Cure53. I only do penetration tests. I don't fix anything. I just break stuff and leave, basically. So I'm a glorified author. That's why I test a lot of pens, right? I also do security fests with a bunch of people. They're not really here yet, I think. And I do Säkerhetspodcasten, which I hope someone heard. Otherwise, I'm sad. How many have listened to it? Oh, shit. I'm famous. And then I did Hackad with a colleague of mine, Linus. I think he's here somewhere in the audience. There he is. Look at him. He's pretty. And David, Ginny as well. It was a lot of fun. Very good that it was a bunch of adults doing that with us. Otherwise, it hadn't become a TV show at all because it was in, yeah, there were things everywhere. So some legalese before we start. This presentation is based out of things that I've found during active engagement. So some of the stuff in here is a bit unorganized and out of bounds, if you can follow along all the way. And that's just the way things are, so let's move on. So, today we're going to look at a large repository of 250,000 lines of code. No, that's not what we're going to do. We're going to embark on an adventure. And this adventure is about the web application horse that lives in the Kubernetes fortress of Doom, which has sort of a loosely attached bond to the SaaS authentication service in the cloud, which lives within a cloud, right? So in order for this to be a proper adventure, we need to have a treasure map, right? Everyone is very quiet, right? Of course, of course. So we have a treasure map. Boom! So the goal for this exercise is we have to sort of convince the mighty web application horse to give us an entryway through the Kubernetes fortress in order to reach the workload village, because you know in the workload village there's a party going on all the time, which is amazing, right? And after we're in the workload village, we need to catch the ferry that crosses the sea of unbreached clusters in order to get to the treasure at the top where we breach the cluster and find the gold. Sounds good, eh? And we have not very much minutes to do this, so it's going to be a bit of a rapid thing, and it's going to be a lot of details. Just go along, and we can talk about it later, because, yeah, this will be it. So the gist of the whole exercise is to find some kind of exploit within the web application horse, travel within that reverse Trojan horse thingamajig, inside of the ingress, into the Kubernetes, into the pod, from the pod, break the cluster itself. Anyone who is uncertain about the goal is, raise her hand now. This is awesome. That was it. Nope. So, the whole idea of this application is that we have a web application, and that one is provided by a SaaS provider that gives you basically a web application with a UI that you can log into and create your logging entries. Like you want to have like SAML, you want to use GVT, you want to do OAuth, you have to have a fancy WebAuthn endpoint. You need all the bells and whistles, right? And that's complicated and takes a lot of time. So no one has time for that, so they invented a project which you implement in your cluster, and then you can build dashboards, and you can do all kinds of shenanigans, and you just have to sort of verify that one token is actually coming from the right sort of SaaS provider in order to get an authentication schema into the backend. That was a lot of information in a short while. Basically, log in, validate, welcome to the application. But it's customizable, so me as a client can change the icons and add some nice CSS and all kinds of cool things. Very secure, obviously, right? So we get this, and when I do penetration tests, I only do code-assisted penetration tests, so I have the full source code. Otherwise, they will spend a lot of money for me to just find one hole. So I always get code assisted penetration tests, so I know what I'm looking for. So I started to dig in to the code and look for stuff. And the basic thing I tend to look at in terms of Kubernetes stuff is user controllable objects or something that get executed by user controllable input. Makes sense, right? So after a little bit of a digging, we found out that the web application has a bunch of values that can be set by the user itself in order to customize the user experience. And that is done using Java EL expressions, basically. And those are validated through a process that is coded in a class, etc. A lot of people is nodding their head. Yes, there will be a classic web vulnerability in this one. Nothing has ever happened with user-controlled EL objects, right? So I'm just going to go right for it. So this is the thing we found. We found a class called password eval, which get executed in your pod in the backend, which is awesome. In the backend in the pod. And show of hands here, how many in here think that the pod is running like Alpine or something? No one? 1, 2, 3, it's running Alpine, of course it's running Alpine. So this gets executed, and anyone here sort of feels what's going on here in this little code example? What could possibly happen here? You don't have to tell me. But what if, we can talk about a little bit about expression language injection thingamajig. So it's basically used in order to, in this sense, it's like controlling the sort of payload that gets sent back and forth. And it's done that by calling a bunch of stuff, basically, in order to change, in order to sort of fit into the application that we're attacking. So this function, armed with the class that we found in the repository, could give us something like this, right? So in this example, we just give them a URL, and then we sort of call the function, and that function we're able to break out of and do curl, basically. And that could be like your collaborator payload and whatnot. So this was sort of the initial bug. The funny thing is with this that I can't really tell you here is that, but I'm doing it anyways, but not in detail, is that this was actually within OAuth payload field. So it's sort of obfuscated all the way to the backend, and then it sort of gets executed. It was really funny in this simple example. So if we're taking this sort of attack payload a little bit further, this could happen. And this is amazing, because this is when the talk begins. So what we're doing now is that we're actually using this EL expression in order to get a reverse shell back to the mothership. And what happens at the motherships? No one? Why do you use Netcat? Come on. No? Okay, you use Netcat in order to get a shell, obviously, right? So then we get a shell, which is pretty cool, right? So now we are the authentication provider, and of course we haven't hardened our deployment, so now we're roots within a pod, within a Kubernetes cluster, laying somewhere on the internet we don't know nothing about. And this is where the fun happens. So this is sort of my specialty. Like, I am the guy who really thrives within remote code execution and server-side request forgery. That's like my whole tea, right? And my sort of focus of interest is within the cloud realm. So getting a server-side request forgery that I can sort of control, or remote code execution with a shell in this case, is awesome. So just so that everyone is on the right term, we have to do a quick recap, right? So what happened? So we found some kind of vulnerability in the web application that is internet-facing, which sort of led us here, right? So now we're inside of a web application. We have a shell within a pod. And now what? So how many in here are like running Kubernetes clusters or are responsible for securing Kubernetes clusters? 1, 2, 3, a few, not many. How many in here know what Kubernetes is? Good.
Otherwise, we would have a big problem. And I guess a lot of people here use cloud services as well, right? Show of hands. Everyone, right? Dumb question. Okay. So we exploited the vulnerability in the web context, which is awesome. That is a cool find. It will be a critical in my book, and I get more pay, and everything is nice. But now the adventure really starts, because now we want to take over things, right? And now the shenanigans starts. So post-exploitation. We made a hole in the wall, and now it's time to reap the benefits. And you do that with tools, right? And I'm sorry to say that the tools I'm going to show you now are native cloud tools and curl, so it won't be that funny. It is automatable. Yeah, we'll give you some one-liners, and you will see a bunch of curl requests from this point on, and there will be a bunch of details. But you don't have to be quick to sort of write it down or do anything. Everything will be posted in a Git repo that you will get the link for in the end, so you can sort of play with this around. Some of the stuff that I'm going to show you now is not, it's like a default, insecure default in cloud environments. So yeah, go bananas. So when we get access to a pod, in this case with root user, we have the ability to do whatever within the pod, right? And since it's Alpine, we do have a bunch of library binaries already in there. Like vget and curl are like the Swiss Army knife of the internet, right? You can do anything with curl. So in this case, we download the tools for the said vendor. So we know that the vendor, for example, is AWS. Then we can download the AWS CLI in order to talk to API endpoints from within the pod. And we already know that it allows egress traffic because we have a reverse shell. So the pod has already connected out to the internet to our machine. So we know that we have internet capabilities. Well, we don't know that we have DNS, but we are able to call out, which is woohoo, good. So we will be able to download tools, and we will be able to set execution bits on the binaries locally because we're root, right? And then like rootless containers and distroless containers and security context and whatnot, they could apply, and that will sort of give us a little bit of a road bump. But basically what we do is that when we get the sort of foothold, we can install the package manager, we can install BusyBox, we can install curl perhaps. We might be able to find some deb repository that we can curl from or whatever, right? So we are able to sort of install stuff. And what I tend to do is I start with kube control in this case, which is the Kubernetes command line interface where all the ninjas live, which is really versatile in this case. So first off, we install some tools in order for us to communicate with internal systems, in this case, control plane stuff. So far, everyone is with me, right? We're off to a good start, because it will go south from here. Default service tokens, or default service account tokens, is something natively enabled in Kubernetes, and it's deployed everywhere, basically. And that is a read-all token that could list unauthenticated endpoints, get information about the cluster, get sort of notion on what's going on and what's happening within the cluster. And those should never, ever be appended any rights to do anything else. Anyone here seen this happen before? That someone might have put some kind of credentials or set of permissions to the default service token within a namespace? That is terrible, because that is available everywhere. And that should not be the case. Then it will make it very, very easy for an attacker to do this, for example. And in this case, you get a list of all the secrets within the namespace admin test1, and then you're able to use those said secrets to do whatever, right? You can decode them, you can use them, it could be anything. It's okay to use the secrets with static keys and whatnot, but you sort of need to protect where they begin and when they start. This is basic stuff, but no one really cares about this. I think it's important to address that this is a minimal change. Never append extended permissions to default service account token. And in addition to this, you don't really need a default service account token ever. So you shouldn't mount it altogether. You don't need it, but it's there by default. So remove that one. That would be a good thing, I guess. Yes. And then we have something else which is pretty funny. I'm just doing this in order to, guys, so you can sort of follow along later on here. It will all make sense. So configuration maps, config maps, it's basically place within the Kubernetes cluster where you could put things that's going to be reused, like build me an Nginx, or pop up me a node thing, or get me a traffic ingress controller, or whatever, right? So it's basically resource verb that could be used to store configuration data, and it should never, ever, ever be used to store credentials. Guess what? All of a sudden, there is credentials there because people map their production templates straight into the config maps, which is not intended for it. It says so in the caution here is taken from the manual, and then you have all your production secrets within the config maps, and guess what? They're readable by everyone. So if you're lucky, you're able to sort of just do a kube control query in order to get all the configs maps. And this is an actual example from a production environment that we did this for. And yeah, then you have the cluster breakout here because you have all the access credentials within the configuration map, and that is readable for everyone within the namespace and whatnot, which is really bad. And then we have the fun things. Cluster control planes, right? So in order to get all this shenanigan to work, I can move this over here maybe. We need to have a control plane, right? And that is something that sort of orchestrates the whole, the whole symphony of Kubernetes, right? So that in the control plane we have the single point of truth, like dictating what's going on. If we're going to scale up, if we're going to scale down, and if we're going to put more resources in the hacked web horse, or if you're going to pull down resources for the hacked web horse and whatnot. So it sort of dictates what's going on in the cluster. If we want to build more pods or more workloads, add stuff, remove stuff, the control plane will be sort of the point to query in order to get this to happen. And that is nice. And we can use that to our benefit. So we have a reverse shell with root access within a pod. We have determined that. But that's no fun, because we're only in a pod, right? What we're going to do? Mine crypto, maybe. If they have like good resource quotas, we may be able to get like a lot of working power for our advantage, but that will not really be the case, right? It's really boring. So what we want to do is that we want to privilege escalate. We want to do things. And this little technique called node impression is the most awesome thing ever. This will be an example from the Google Cloud now. So we're going to shift clouds back and forward now for the one who's not already falling asleep. That will happen. So in this case, we will use Google as the example. So in this case, a Kubernetes cluster, a GKA workload, guess what? It's a Kubernetes cluster within a Kubernetes cluster running in Google. Holy, right? So in order for us to sort of scale up our own cluster, we will, the nodes or the master nodes or our Kubernetes cluster needs to tell the backend that, hey, we need more power. And we need to be able to tell that to the Google endpoints in order to get more resources, right? And that is done through a bootstrapping technique that is generated by our Kubernetes cluster. So our Kubernetes cluster says more juice, and then we get more juice, and this is the way we get juice. So in this case, we are asking the metadata layer or the control plane of the cluster to give us the contents of the kube environment. And that is basically the certificate for our sort of cluster in order for us to sort of, spin up more resources. Fair enough, right? So we are able to download those. Do you think we can use them just straight away? Would that make sense? No, that is not doable, sorry. But then you come to think about it. Why are they even there then? Right? So if we are able to query these, why are they there? What are they used for? Anyone knows this? Show of hands. I won't stick you to it right now because this is sort of my talk. But if you know it, raise your hand. This is so sad. Yeah, okay. So they're there to bootstrap, of course, that's what we said, but we can't use them, right? So something is off. So we were able to download them, but our cluster says that we can't use this because it doesn't have permissions, because the certificate isn't right, probably, right? So then we can skip ahead, and then we can ask our cluster to help us create a certificate request based on the certificate that we already had, that we got from the cluster. Which is pretty cool if I do say so myself. And then it's like, okay, but could we use that one then? Nope. Why can't we use it? Because we don't have the private key, right? So we have only 2 parts of the threesome, basically, right? So we need the last part. But how does our cluster validate a PKI that lives in Google Cloud? How can that sort of validate the certificate chain? Can it do that? If so, could that be a breach of sort of privacy? Because then they sort of have our sort of certificate chain? Or is it just that they sort of trust certificates? So what if we do this? What if we do this? Will this work? So now we're actually signing this. We're just creating a new certificate with the certificate request thing that we just received, signing it, making it locally. And guess what? We're using the same service that we used before, putting it out to a file with the request file that we just created, and then boom. We're able to query the cluster, and we're able to get all the master nodes and all the secret shenanigans within the cluster. Pretty sweet. And guess what? This is native configuration. This is on by default in every Google Kubernetes cluster out there that has not enabled shielded nodes. Pretty cool, eh? So this is really bad, of course. Like now we're sort of impersonating a node, and the node is like the adult that runs all the pods, right? So now we sort of have access to basically everything that a node has access to by impersonation, which is really, really bad. And Google knows about this, and the action you have to take is that you have to enable shielded nodes within your console, or you have to ship a brand new cluster with the shielded nodes enabled by default. Otherwise, this is vulnerable today for node impersonation. Pretty cool. There is a bunch of tools in order to automate this whole process, but they doesn't really show what's going on in the background. But this is pretty nice. And this is not only valid for GCP, it's working on AWS EKS as well. Different endpoints, but the exact same gist. Okay, moving on. So now that we are a node, it will be awesome to become the actual GKE instance, the actual have a shell within the node, that the server running the node, right? That will be even cooler, isn't it? And then we have this guy, Duffy Kool-Aid, so created this amazing one-liner that spawns a privileged pod, basically, with an image of your choice, and then, spawn it as privileged. What can you do with a privileged node? Anyone? Exactly, you own the system. Like, this is not virtualization, it is a container. We're actually using a small pizza pie of an actual machine, and if we're a privileged pod, we're basically that machine. And then we can do stuff that we've seen below, but in the GKE clusters, or in the default configuration of the GKE cluster nodes, now the instances running your nodes, they don't have anything installed. So you have to start with, pulling maybe a package manager, or maybe BusyBox, or whatever, in order to sort of get something to work with. You know, we need to have our curl in order, right? So that you sort of have to install as well. But since you're root now, you can do that. So that won't be a problem. So then you can sort of download the utilities that you need using internet, and then patch the node itself in order to, query resources on that node. And in var lib, you can understand what's going on there. You can see all the overlays, you can see all the file systems, you can see everything that is mounted for the running infrastructure within your Kubernetes cluster. Everything. Pretty cool. But we're not done yet. In addition to this, we have something called deployment frameworks. Anyone here heard about Helm? Cool. Are you using the Tiller service? No one? Or don't you want to dare to say that you're running the tiller service? Nope. Okay. Good. The tiller service should never be used anymore. This was a thing back in, I think it's 2 years ago. This was sort of announced. And you can basically do the same thing as the node impersonation, but you could do it in the app context instead. So you don't have to impersonate a node. You can do it for a deployment set as well, which makes sense, right? Because it has a unique name. It's bound to the same sort of certificate authority, the PKI, and whatnot. So it makes sense, right? It's not that bad. So in this case, you could impersonate the Helm and Tiller service, which is responsible for deploying stuff to the cluster. Guess what? Probably they have pretty high permissions to the Kubernetes cluster, right? Could be. So if you're able to impersonate the app deployment for Tiller, you then would be able to get the token for Tiller, and the token for Tiller will give you basically, system administrative access to the entire cluster, which is pretty cool, in my opinion. I don't know about you guys, but I think it's pretty cool. So now we've pivoted a bit within both sort of the cluster, and we sort of broke out a little bit back and forth. But the thing is now, when we have this sort of plethora of nice things to run around with, we're able to break out to the GCP instances themselves. How am I doing for time? Pretty good, actually. Holy, that's good first. But there is more, of course. So the instance metadata, or the user data that is collected by resource verbs that has an instance basically in all the clouds, they have to be able to use some kind of ephemeral data set or storage object in order to get objects to ship to their configuration in order to make things go boom. And one thing that I've seen deploying in modern deployment pipeline is that you are using this in Bootstrap scripts or Cloud Init and whatnot all over the place, which is awesome and makes for a really good and coherent deployment process. But the problem is that we don't clean up after ourselves. So imagine you find a server-side request forgery as an EC2 instance. Are you able to read that instance user data then with the key that just leaked? Anyone think that's the case? Everyone is so nice and quiet. Yes, that is the case. You're able to read those. And guess what? They contain a lot of nice things. They could contain, like I did an assignment last week where the entire COPS manifest was present within the user data attribute with all the init hashes and everything. The entire sort of COPS's Kubernetes operations is like a template-based Kubernetes thing. If you're thinking about going the Kubernetes way, and you Google around and it's like, oh shit, this Kubernetes thing is really hard, but COPS looks really nice, don't install COPS. Don't do it. It will just cost you more money because it is template-based and you will get a cluster that works for like 5 minutes and it's working, but then you will spend so much time trying to fix all the holes in it, so don't do it. Just start with something else. That was a side thing. But yeah, so the user data attributes are really nice, and if you're doing penetration tests within an AWS context or in Google, you should always query these. But then he's like, oh, yes, but you don't know what you're talking about. They have 4,800 and gazillion user EC2 instances and whatnot. Fear you not. We made a bash script for this, of course. So we made this cool little one-liner that actually queries all the profiles, and that can take the profiles from an input file, and it will display it like this. Or you can put it out to a CSV or a JSON or anything. This is something really exotic you're witnessing here. Can anyone say why this is a bit vague to be in the user data attribute of EC2? Because this is what it is. Anyone knows why it's a bit weird? Come on! No? No one? It is a Windows command, right? That's not really common, is it? Is it? Are you? Okay, let's do this instead. Show of hands, how many are running EC2 instances, Windows EC2 instances? One. You see? It's exotic. Good on you, sir. Keep doing what you're doing. But this is pretty fun. So someone logs in, add themselves to the local administrative group. That's a good find, right? That's pretty cool. This is rarely the case. Like this is not what's happening most of the time. But most of the time I found really cool stuff like setting up a cluster, setting up environment variables, not using the secret manager instead, using it to bootstrap the environment that is spawned, right? So the problem that you should really clean this up after deployment. You should go in and scrape this so they aren't there. It's really important. And this bash one-liner will also be available after this talk. So it looks like this. So it will take the instances, basically, and it will use a profile that you sort of add. You can use whatever. And then it will take do the query against the API endpoint. It will decode the base64 blob. Because, yeah, user data are stored in base64 blobs, which is the best encryption schema out there, isn't it? So, yeah. Is perfect. So yeah, and then it sort of spits everything else, and this could be used in different instance verbs as well. It has to be EC2. It's just everything that has a user data attribute. Cool. Yeah, so it's time for a recap again. You have been waiting so long for this. Basically, I have been waiting so long for this because now I get to show my cool map again, which is pretty cool. So what we did now is that we sort of basically abused the web horse. We used the web horse in order to ride into the city of the work village, basically, to sort of haggle us a ticket. So we were able to sort of cross the sea of unbreached clusters and get into the cluster and then beyond. And then beyond has to be the next talk, I think, basically. So yeah, the thing is you should always know what you're deploying, otherwise things will go wrong. And if something sounds too easy, it probably is. And there is no excuse not knowing what you've deployed, basically. So in order to summarize this a little bit more, security is hard. Kubernetes is harder. Cloud concept is really hard because it's changing every time. And it is sort of a moving thing that you sort of have to shoot on volley. But it will be very good to sort of define where your business starts and ends in the concept of where you put stuff. I am a firm believer that automation should happen everywhere. So in my opinion, I think it's feasible to do automates or sort of threat intel on your access logs, for example. If a web application starts to curl or do a reverse shell to a server that is owned by a security researcher, that should be something to look for, I guess. And that's really simple to add, like a really simple block rule or something. So egress filtering is basically what I'm saying in order not to be able to do exfiltration or create reverse shells. But in all honesty, I'm full of shit saying this because everything that I showed you now is queryable from the endpoints, right? So when we get the tokens, the Kubernetes tokens, we can query the public endpoints of it. Or if we get a security secret key for AWS, we can use that to query the API endpoints. So that has to be like, then you sort of have to have an ingress gateway in order. It's a long story. So it's not a linear thing, but I think it makes sense to look at your application logs and see what your application is doing. And if it's starting to do weird stuff, installing BusyBox on the node that you don't really are into because you're only using next, that is sort of a big thing. And I think that you should enforce and implement linters to your infrastructure code repositories in order to find obvious insecurity faults. Like Terraform is really cool and it's really fast, but it's also template-based and everyone in here is lazy. Me also, of course. So we will use everything that works and it has to work fast and then we just skip it, right? So linter, that is a good thing. Think about the big picture. Everything is connected. Separation is key. Okay. And now we have an announcement. This is cool. Now we're stealing another conference. So the CFP for Security Fest is open, and we want you guys to submit your talks there. Same thing that Skjortan did before here. I'm just doing this. Send your CFP here. We're changing venue, which is a world first announcement. No one knows it except you and internet now. So we're changing the venue to the city center of Gothenburg. So we'll be at Elite Park, which is smack in the avenue. Oh, you know. we will be there, and that will be a lot better because it will be take more people, and we will be able to do more cool stuff, which is cool. And that's about it. We made it to the end, guys. Yes. Yeah. And I'm basically on time as well, right? No one is angry. So any questions? We got one here. Do it. Should we use the mic? Yes, we should
Is
use
on?
the mic.
Hello?
It's on.
Okay, so if you do this as application as code versus deploying containers, which one you think is more likely to fuck up?
Both.
Both?
Like everything that we build is like I don't believe in the human race as something that is good on doing something like aligned with common practices, because get bored and tired and do shenanigans all the time. So everything that is customly built is prone to break, basically. So it doesn't really matter in which context. We will find vulnerabilities in everything that we put our hands to, I guess.
Yeah. Thanks.
Anyone else? Don't be shy. Come on.
So I saw that the password was summer 2023 exclamation mark.
Yeah.
Was that the real password?
No, it wasn't the real password. It was actually a good password. It was a good password. I just had to do that in order to sort of, but it is pretty common. Like you should talk with Linus. He does this all the time. We have like a betting pool on how many % of a domain actually has this really shitty password. And you would be surprised. There is a bunch of them. Anyone else? Yeah, if you're shy to talk to me now, you can just find me later, I guess. No? No one else? I can't see any more hands. There we have one. One brave gentleman.
Hey there. Oh.
Yep.
Have you seen any good defense mechanism? Like there are like CNCF Falco, there are Calico for egress
There's a bunch of
blocking.
nice things. I talked about with Franzi, I tested a project that looked really cool, but I can't remember the name of it. I can look it up. This was so weird. I actually tested them, and I can't really remember their name. But they will be adopted to the CNCF, or the Cloud Native Computing Foundation, soon. The cool thing with that one is that they built their own repository for containers, basically. And how is that different from Docker Hub or Harbor and whatnot? Yeah, the difference is that they built context around their containers. So they get you a YAML configuration context, like a security context, that is hardened by default. So let's say they have a node image, and that has a bunch of hardening features attached to the YAML construct from the beginning. And then they have built native support for SBOMs and stuff, so you sort of can have a dependency validation form going with you as you deploy this and use this. So it's not a distroless container. That's what I said on the scoping meeting. Oh, this is like distroless containers, and they almost shot me. It's not like distroless containers. It's just like they have defined a security context for a specific build, which is pretty cool. So there is a bunch of initiatives. And like the whole Google node impersonations thing, you can actually, with a checker, remove this, and that won't be a possibility anymore with shielded nodes. Yep. Anyone else? No? Cool. I'm done.
Okay, thank you, Jesper.
Thanks.
So we're going to release you guys for 10 minutes, and we'll see you all back here in 14:05. Thank you.
ransomware as a service.
Ja.
Och huruvida kriminella, kanske mer
Det är
traditionella
jättevanligt.
kriminella. Det är det? Ja. Har du tid att prata lite om det sen, eller?
Det kan
ska
vi.
du köra igång här?
Ja, jag är klar.
Du är klar? Okej. Ja.
Men vill du titta så kan vi...
Nej, jag tänkte mer att om du...
Ja, vi kan ställa alla. Vi ska bara placka ner den här. Så kan vi ta en liten snabbis.
Sorry.
Ja, det gör vi. Jag lägger den här. Jag ska bo här.
Hello everyone, it's time to start making your way back into the main room for the next presentation. So if you want to see the next talk, it's time to find a seat. There's still plenty of seats available. So we're going to give people 1 or 2 minutes to make it back. Next presentation is starting very soon. So if you want to see the next presentation, find some seats. And while we're waiting for people to find their seats, I can just say that I really like the title of this talk because I'm so old. So when I was a kid, this was an oxymoron that couldn't happen. So that's one of the reasons why I really like the talk. It's like, wow, you can have. I'm so old that I haven't used Windows and Windows 2000. So I'm like, wow, they have SSH now. This is amazing. So yeah. Without further ado, I hand it over to our next speaker, Matthew.
Hi everyone, can you hear me all right? Yep, cool. So today we'll be speaking, as the title suggests, about methods of lateral movement in Windows OpenSSH. So first off, who am I? Matt Lucas. I realise that's a very UK-centric joke for a Swedish conference, but Bake Off is good. I'm a security consultant at WithSecure. I generally like to hack all things kind of Active Directory, all its individual fun components, and I kind of dabble in Azure as well. So basically, my happy place is screwing around with things Microsoft has made. I'm going to be speaking today about Windows OpenSSH, and yes, specifically OpenSSH. Microsoft and the open source community have created a full-blown port of the actual OG, like OpenSSH repo, basically for Windows. A lot of people still don't realize this, right? You don't need to install PuTTY anymore unless for some reason you really like it. If any Windows 10 or 11 device now, if you open up your laptop, do SSH -- version, there's going to be a client installed there. There's also a server-side component, which you have to manually install, but there's a nice shiny version for you on like PowerShell Gallery and everything. So if you've ever kind of gone through the full list of like supported authentication methods in OpenSSH, like OG Linux, you'll know that there's this giant, huge list, far longer than anything that anyone actually uses. Microsoft and, as I say, the open source community have so far just ported over kind of the 3 that anyone ever seems to use, i.e. password, public key authentication, and sneakily GSS API authentication, which I'm going to use interchangeably with Kerberos authentication for this talk. Those of you who watched the DEF CON talks this year know that there was a recent fun vulnerability in GSS API authentication for Linux OpenSSH. I won't go into too much detail here for time, but I've had a little poke that fortunately Windows doesn't seem to be vulnerable to that exact thing before you get too excited. As you can probably guess kind of from the title of the talk and the fact that I've launched straight into authentication methods, this is basically going to be the crux of where kind of lateral movement vectors arise. And a lot of them are going to basically be more or less rehashes of the ones that we already know in Active Directory, but with a few kind of OpenSSH quirks. So just super high level, if you've got one server, you've installed OpenSSH server on it, and you're one computer, and you want to authenticate to it, you go to it, you say, hey, I'm me, here's my password, my cryptographically signed whatever to prove who I am. The server does both the authentication and the authorization check then. So it will say if your password, whatever, is correct, and it will check its access control list to decide if you're allowed in. When you add in Active Directory, this gets a little more subtle, I suppose, and this is where a lot of the kind of confusions with OpenSSH comes, or really the vulnerabilities, the opportunities for misconfiguration. Essentially, when you've got one server, it handles both authentication and access control, and you kind of, as someone setting this up, don't have to worry too much about like both. But when you introduce Active Directory, you now have an external identity provider that is checked against, and kind of the way it checks against this isn't always like the best way, pretty much. A lot of what we're going to discuss, and I'm sure you'll be able to spot which bits are also going to be applicable when you plug Linux into Active Directory too, and let SSH use that. So we're going to start with just a quick overview of kind of how the different authentication schemes work, super high level. If you're using password authentication and you've plugged in Active Directory, then instead of just having one server that you give your creds to and that's it, you start by connecting to the server, you give it your password, it then goes to Active Directory on your behalf and checks your password for you. And then Active Directory comes back to it and says yes or no, that's the right password. At which point the server makes its access control decisions. Public key authentication is pretty well unchanged. You speak to the server, you prove that you own the private key for which it knows your public key. And behind the scenes, there's a little bit of chatting with AD, getting a non-forwardable ticket, seemingly as some sort of bookkeeping process, but it's not anything that's sort of super important, basically. Feel free to prove me wrong on that, you pesky hackers. And then Kerberos authentication is just the standard Kerberos authentication flow that anything that uses Kerberos uses. You go to Active Directory, you say, hey, I've got this TGT that you gave me earlier, proves I'm me, give me a TGS for that SSH service, and you get it. The specific SPN that is used for SSH is it's the host / FQDN of the server thingy. There's not like a specific SPN that gets created for SSH. So to explore the ways in which these three authentication schemes can kind of go wrong, we're going to talk through a fictional attack path from a fictional company called Radiance. They are huge fans and adopters of SSH. They loved it on Linux, so as soon as they knew there was a native port for Windows, they plugged it straight in. One of their users, Kaladin, has just been phished. Your favorite Privesc vector, whatever it was vulnerable on his machine, and now the attacker has both his NT hash and a foothold on the Radiance network. But can we use an NT hash? None of those authentication schemes seem to really play with NT hashes. With password authentication, the server speaking to AD for you, there's probably some NT stuff going on there, but none of the stuff you're doing is NT hash specific. Indeed, password authentication, it needs a password, not the hash. Key authentication needs a key, no surprise there. Kerberos authentication, though, we can kind of get away with that in certain situations. This isn't a super new technique, right? This is something called overpass the hash. Essentially, in scenarios where requesting Kerberos tickets with NTLM hashes enabled, you can pretty much go straight back to more or less passing the hash, even in things that support Kerberos rather than NTLM directly. So just as a super simple demo, if the play button will appear for me. Ooh, I love PowerPoint online. All right, whatever. So I'll just tell you what's in the demo because oh, there you go. So there's our friend's NT hash, one that I made earlier. The process of getting the TGT is as simple as in packet get TGT with the hash, which if that's supported will work. set your KLB5C cache variable if you're using Linux, do some other stuff if you're using Windows, to where that's stored. And then you just chuck in SSH with a -K flag, assuming you've, in the background, configured, GSS authentication, yes. You've got DNS working properly for this DNS thing to work, your clocks are synced, all that wonderful stuff. You just chuck in a -K flag, and in you go. So I've run here, you'll note whoami/groups. That's intentional, just to kind of highlight just a minor interesting point that if the user that you're authenticating as has administrator access to the server, it's always available. You're immediate into a high integrity session. I mean, this kind of makes sense, right? How are you going to pop up a UAC prompt in SSH? But just something to be aware of. So, we've been through kernel authentication. It's pretty simple. It's not really anything super profound and new. Let's have a look at password authentication. So just a quick refresher. You give the server your password. It chats to AD for you, and AD tells it if you're who you say you are. But what do processes on the server then actually see? Well, funnily enough, this does actually leave an NT hash sitting in memory, which is why I think it's that's probably actually what it's passing to Active Directory. The server's like creating an NT hash out of your password and passing it on. But in order to do that, it also has to at some point see your clear text password. It's making like an encrypted network tunnel when you initiate kind of this whole authentication process. But within that tunnel is just your password, right? If a Linux client doesn't know how to make an NT hash, why would it? And just to demonstrate there that yes, indeed, you do leave an NT hash in memory, in LSAS memory, if you authenticate this way. What this means is that if we're in a position where we can watch the Windows APIs, we can recover clear text passwords. Now, this is an upgrade from the scenario where we're just stealing NT hashes from memory, right? If we pop a server that a bunch of different admins are logging into, RDP or whatever, we can only really recover hashes if we're not doing some clever keyloggy stuff. But now, if they're logging in with password authentication and we have admin on the server, if we're watching that API, that multi-byte to wide char API, we can see passwords. No prize for guessing that in this scenario where, just for simplicity, that's a local user rock, their password there, air6 lowlanders 123. Yeah, it just goes through that API, that Windows API. So a very, very similar technique was weaponized before in, I believe, NDSEC's research, a tool called RDP thief. Essentially, this is kind of exploring the opposite scenario where you've compromised some users' like client machine, and you hook the APIs that the RDP, the MSTSC.exe client is using. So you as a little bug there, listen in whenever an authentication like request is made by the MSTSC.exe client, and just it spits out to a file. The reason why I wanted to call out the RDP thief specifically is because essentially the SSH version, the easiest way to get an SSH version is to just steal their code and swap the APIs you're listening in on. So instead of being on the client, we're sitting on the server, and we're just listening in to what comes through that those APIs instead. Obviously, yes, you can engineer this yourself with DTORs, NT, whatever it is, but hey, RDP thief did all the work for us already, hey. Okay, but then so how do you actually get from one to the other? Like I said, you just swap what API you're listening into. So in this splash of crappy code, we've got, we're importing like the original multi-byte to wide char API, creating our new one that basically just calls it, outputs that LP wide char string variable to something else that again gets written to a file with the right credentials, function. And all the difficult stuff of that is done for us by DTORs, yay. But how do we actually weaponize this? So if you ever use RDP thief, you'll know that kind of the default way that's talked about in the repo is to basically use a Cobalt Strike aggressor script that listens for or waits for MSTSC.exe, so that's RDP client processes to spawn, and then inject a DLL into them. for my money, I think the simpler way to do it in this instance is to do something called DLL, it's search order hijacking. So essentially, the sshd.exe process that lives in C, Windows System 32, OpenSSH, sshd.exe, will try and reach DLLs that don't exist. If we have admin on a box, we can make them exist, and we can put whatever we want in them. Again, not a super profound, not a super new technique, but still something that's super useful. And we can use wonderful tools like netclone to basically make sure that when we put our malicious DLL in that directory, SSHD can still find the functions that it's looking for. We don't just break it and, then get no credits because no one can use it. So, quick and simple demo again. There we go. So just proving nothing in seektemp. Oh, I wonder what directory creds are going to end up in. Nothing funny in C, Windows System 32, OpenSSH, just sshd.exe, etc. And we're going to SCP across our SSH user env dil. Now, SCP here is going to use our Kerberos authentication from earlier with no fuss. If your DNS is fine, your kerb5.conf is fine, it'll just use it. Yada, yada, yada. And across it goes. And because we saw that Kaladin was an administrator on this server, this camp management server, it quite happily just put our pre-prepared userenv.dil into that C Windows System 32 OpenSSH folder. ITO. Come on. All right, and then we wait a little bit, maybe a user's going to log in, maybe they're not. SCP back across the file that contains the lovely, lovely creds, and just cat it. The reason why I'm catting it instead of grepping it is because there's some funny character set business going on that I haven't yet properly sorted out. But if you scroll up and down like a silly sausage and probably go past the password a couple times, there we go. We can see that when the user Dalinar logged into the server with pass authentication, we got their domain password, ilovehonor123, easy peasy. So, again, it hates changing slides when there's a video on screen. Wonderful. Probably Microsoft's revenge. All right, so what about the SSH client? All this talk has been on the SSH server, but just as a quick side note, can we do the same sort of stuff there? Well, if we want to sniff creds on the server, we need to listen in on the multi-byte to wide char API. Can anyone possibly guess what API you got to listen in on the client? Anyone? Wide char to multi-byte, easy peasy. Exactly. It does it one character at a time. You can also use this API basically as a keylogger as well. It will just output everything that the user is typing. So again, kind of mega loud. You have the benefit that at least you're just listening on this API for that specific process, not the whole system. But still should be quite handy. And again, SSH client.exe or SSH.exe also tries to call to DLLs that quite simply don't exist, which is useful. But anyway, so we've been through those two authentication schemes, password and Kerberos. Key authentication, we've kind of hushed right past because the main interesting vulnerabilities there are basically the same as the Linux ones, right? Protect your keys, put a password on them. If the password is, if you put a password on them, don't make a crap one. Easy peasy. Those are slightly more interesting. But where I think it gets really interesting in SSH, and where I've kind of seen more valuable impact in actual engagements, has been really around the access controls, and in particular, the default configuration access controls. So essentially, access controls in SSH are configured through the sshd config file. Same as in Linux, just the location is different, right? So you define things like allow users Caledon, and oh, surprise, surprise, that user can get in. Allow groups, same thing. Deny users, deny groups. You know, nothing weird going on there. If anything is declared in these access control lists, then that's what's followed, and everything else is blocked. So say you got to this point where you just put in allow users Caledon, Dalinar couldn't log in. Yada, because he's not on the list. But if nothing's declared, then effectively that means you've got no access controls, and anything with valid authentication can log in. Which, I mean, if you're one server, like the old, classic, you've got one Linux SSH server, I mean, that's usually not a problem, right? Because why would you make a local user if they couldn't get in? But I think you can probably guess where this might be going, why this is a bit of an issue in Windows and really Active Directory environments. In fact, not even Windows specific, Active Directory specific. Yada, yada, yada. So if AD is not in play, then, and you haven't defined anything, then user Dalinar gives server its password. If it's valid, it says, cool, I recognize you, you're a local user, I haven't been told to do anything else, come on in. Which again, why would you make a local user if they weren't supposed to log in? I know there's many reasons, but yada yada. But what if Active Directory is in play? Well, you say to the server, hi, I'm me, here's my password. It says to Active Directory, is this user's password? Active Directory says yes. And then, the server's not been told who to let in and who not to let in, so I guess you're in. Yeah, as I said, I imagine so a lot of you can kind of see what the issue is here. If you just go and install right now, OpenSSH server from PowerShell Gallery or whatever, and don't configure it in any way, and you're in Active Directory, then any user can do this and just SSH into your machine, easy peasy. But luckily, no one would do that, right? And then just an example, so if you're in the situation that we were just in, where suddenly you've got plain text credentials of a domain user, who cares who, just chuck it in crap map exec, easy peasy. And the size of this list is only going to be limited by how much money I wanted to give my cloud provider for the size of my lab. But I've seen much bigger lists than this light up. Okay. Right, so defending OpenSSH. How do we do it? So I wanted to first kind of go through what the pros and cons were of these authentication schemes, like from the perspective of someone wanting to actually set up SSH, defend it, use it properly in a Windows AD environment. So password authentication, kind of the pros are obvious, right? Everyone knows how to type a password in. And, okay, not being able to pass the hash is actually a pro, or overpass the hash in this instance. But of course, plenty of cons with this one. Your creds are exposed to Windows APIs, an admin can steal them. Empty hashes in memory, for some reason, stealing the plain text stuff is an option. And I guess technically there's the old school concern why people were already swapping from password auth to key auth, which is your local accounts are, technically more brute forceable. Key authentication, this is kind of, biggest pro for me really is that this is kind of familiar as like a relatively secure option. You can configure it pretty securely as evidenced by the fact I didn't have an interesting attack path to show you today. Same pros as before around brute forcing. One of the neat things as well is that if you want to use keyauth for an admin account, Windows forces you to have like decent file permissions on the administrator authorized keys folders, files rather, meaning that you can't just use this as a really stupid easy privileged vector. SSH just won't work if you set it up that way. And of course, there's nothing interesting that leaves in memory because you're not putting your domain creds in. You're using a public key, which is a different thing. And then the cons again. The important ones are the same ones as Linux. Don't leave your keys in stupid places. Put a decent password on them. And then Kerberos authentication. I put both the pro and the con as most natural integration with AD. Anyone who's kind of hacked AD environments can appreciate that. but more seriously, there's no. This doesn't seem to leave any sort of interesting, useful stuff in memory that you can go and pop the rest of the environment with. Is vulnerable to overpass the hash and pass the key, and it doesn't seem to be vulnerable to that recent GSS API vuln that dropped at DEF CON this year. And yeah, I mean, by integrating with AD, it's the most kind of centrally manageable users, as in the users are the most centrally manageable out of all of them, really. And then kind of after all of this stuff I've talked about opening these massive holes and what have you, and bringing in these kind of familiar techniques in a new context, should you actually use Windows Open SSH? On the pro side, I would say there is a genuine benefit to being able to administer both your Windows and your Linux estate with one tool, right? Complexity brings security holes, so having it all under one thing is an actual useful thing, and I think for security too. The default configuration being horribly insecure is depressing, especially since you can't stop your, I'm sure with proxy controls and what have you, but in general, you can't stop your server admins from just opening up PowerShell, running, add Windows capability, open SSH server. Back on the pros, it is easy to use, which is good. But back on the cons. The way that you configure it through this SSHD config file, it makes your life hard to actually enforce a centralized good config, right? If it was registry keys or something, you could use group policy to easily just set good ones throughout. But it being some set of files, it just inherently makes it a bit difficult. It's not impossible, just not kind of natively easy, which makes that last pro harder to achieve, which is that, you can configure this securely, but your life is just harder in doing so, or at least forcing your whole estate to do so. Just on the point about kind of group policy, and just the point about centralized management in general, really all the things that group policy specifically offers you, at least so far as I've dug about, is pretty much to restrict it entirely, which is a bit boring, or you can technically push a known good SSHD config file across the place, but then you kind of have this one-size-fits-all issue. The preferred method I would suggest would be to try and get in during the provisioning of your servers. And basically, from the start, introduce a known good SSHD config file, during your SCCM task sequences, your golden image provisioning, whatever it is. So the first step of that being choose the authentication method that you want, that your environment is best suited to deal with securely. And then in whatever way you provision it, as an example, PowerShell, add in, yes, do use the authentication methods I like. No, don't use the ones I don't like. And then make sure that there's some sort of access control list that you're happy with, right? So in this example, I've chucked in just allow groups, your domain / your host -SSH or some local SSH groups. Basically either a domain group or a local group. Pros of domain group, you can centrally manage it. Cons of domain group, an attacker can enumerate it. Up to you to weigh up, basically. To be honest, I'm not quite sure why something like the local SSH thing that I've put there isn't by default, right? When you install remote desktop on a Windows machine, it creates a remote desktop users group, and that's who's allowed in. I don't really see why that's not the default for SSH, but anyway. Okay, right, on to some detection points. The detection points, I'll be honest, aren't super useful or super incredible in this scenario, basically because it's the age-old question, how do you distinguish between legitimate use of a remote access tool and lateral movement, right? It's all context. Kerberos, if someone's doing this over past the hash technique, you can use the standard detection for over past the hash, which is if your environment is all AES tickets or AES-based Kerberos tickets, and just one thing's using RC4, then hey, maybe that's something dodgy, or maybe it's just one of your apps misbehaving. It's the woes of detection. password authentication, there is something, it's a little bit more clear-cut, but still very much environment dependent. Specifically, there are some artifacts left behind by someone doing that crap Mac exec thing that I showed earlier, basically taking all your domain that has SSH exposed and just trying it. One, you create, a CE user's username directory by default if you successfully log in. And two, you cause a logon event of type 8, which, if you can read, there is network clear text, which is very weird for my money. I'm sure there are some legitimate uses that me, as someone who breaks things rather than makes things, hasn't considered, but that's weird. Obviously, the reason behind the name being it's a network logon, but Windows receives the credentials in as far as it views clear text. Obviously, it's through an encrypted SSH channel, but by the time Windows is processing, that's already happened. Yeah, other than that, I'm sure there's cleverer things you can do to detect things like the API hooking in the SSH thief example I've given. But in general, I think the most powerful tool for this stuff is basically baseline your environment and just are people doing weird things like, I don't know, some user who's never used SSH in his life, suddenly SSH into your prod DB. Weird. Okay, so just final word from me. So I haven't seen super widespread adoption of Windows OpenSSH. Yes, the client is installed on all your machines already, but the server I've only seen used in kind of a few environments. But when it is present, it's very common for it to be set up in the dangerous default. And you may have noticed, if you're nerdy enough, that the whole naming scheme of this has been Stormlight Archive, but please, I'm only halfway through book 3, so no spoilers, thanks. Okay, and that's me. Thank you very much. All right. All right. Cool.
Okay, do we have any questions? Oh, one more.
So I'm curious about the way you are recommending configure SSH with the configuration file. Pretty much any modern version of OpenSSH allows you to include an external file instead. Shouldn't that be an easier way to distribute the configuration?
Sorry, go again. What was the better solution you're suggesting?
You can use an include directive and then just include whatever configuration file you are distributing over the Active Directory or, for example, over Samba.
Yeah, that sounds pretty good to me. Let's speak afterwards. I think that sounds like a good idea.
Thanks for the great talk. Just wanted to thank you for including some hints to forensic analysts in your talk. Just wanted to say thank you for that.
No worries, yeah. That is a personal point of mine. I think it's cruel for us to release attacker techniques and just leave the good guys out in the cold. Yeah, sorry that they're not any better, basically.
Okay, thank you so much.
All right, thank you.
Let's take a couple of minutes of a break, and I'll see all you back here at 5 minutes to 3. Thank you.
functions such as CPU, memory, network, and so on. Then we have SecComp, which is an acronym of Secure Computing Mode. This kernel feature allows us to restrict actions available within a container down to the granularity of a single system call. And lastly, we have capabilities. So what are capabilities? Capabilities provide the ability to give a specific set of privileges to a third process. They do so by breaking down the dichotomy between privileged and unprivileged that embodies all or nothing into logical groups of privileges. All privileged actions have been thought out and categorized into approximately 40 capabilities. That means that a process or thread can use a small set of action for only those that are needed, lowering the danger of abuse to unexpected behaviors. In other words, the purpose of capabilities is to divide root privileges into distinct ones. Capabilities can be applied to container processes, and in this way, all processes part of the container can inherit its capabilities. So what happens when a capability is assigned to a container or a process? The call thread can execute a set of system calls associated with this capability. We can see some examples of system calls that are directly connected to a capability, for example, init module and delete module, which are responsible for installing a deleting module inside the kernel. They are associated with sys module capability. We can see ptrace and process VM write v system calls directly associated with sys ptrace capability, and mknode associated with mknode capability. So all groups of this capability combined together will be considered as root privilege and will make a complete set of permitted system calls. Here you can see an example of how capabilities enables the breakdown of the dichotomy between root and non-root privileges. So you're probably wondering to yourself where those capabilities actually stored. When the process is created, it dynamically allocates a task structure. So let's take a look at the structure on the left. This data structure contains all the information to manage a process, such as process ID, its stack, and a pointer to a parent process. But the most interesting part for our talk is the crest structure at the bottom of the structure. You can see it on the right. This structure holds the security context stuff for the task. This structure, we have the UID, the GID, and the SUID, and lastly we have the 5 capability sets. So this is the 5 capability sets we have. Firstly, we have the inheritable, the bounding, and the ambient, but the most important for our talk is the effective capability set. This is the capability set that the kernel looks at when it tries to execute specific system calls. Another important capability set we have is the permitted capability set. This set holds the capability that can easily become effective using some system calls. So which capability should we use? To determine which capability should we use, we need to monitor which system calls our containerized app is using. Then we can inspect the source code of the system call and look at the security checks that are usually located at the beginning of the function. One of the security checks that the function performs is whether the permissions of the task allows the execution of the function by running the kernel function capable. The capable function receives the name of the capability as an argument and returns true if the current task has given the capability currently available for use, and false if not. In this example, we can see the init module system call, which is responsible for installing kernel module in the kernel. You can see that after initialization of some variables, it calls the main init module function that calls the capable function to check whether the capsys module capability is available or not.
So by default, containerd and Docker runtime start their container with those limited set of capabilities. You can see here very important capabilities that in charge of very important actions of the system. For example, you can see here the capabilities of set GID and UID, and the cap, net bind, and net row, which are capabilities that in charge the entire network functionality of the process. It also worth mentioning that Kubernetes uses containerd by default, so actually those limited set of capabilities are actually came by default on new Kubernetes container, on every new Kubernetes container. So how we can control our capabilities in our containers. So here you can see the command line that you can use to control your capabilities. You just need to execute the Docker run command with the parameter cap add or drop, depends on the action that you want to perform, and list the capabilities that you want to change. You can also just write all to do this action for the entire effective capabilities. In Kubernetes, we can control our capabilities using the security context field. It's very easy to use. You can take a look at the snippet and see that in this example, in the security context field, we add the sys module capability and drop kill capability. So now let's talk about privileged container. By default, container don't have any access to any of the devices that is located on the host. However, when container runs in privilege mode, it has access to the entire of the devices that is located on the host. When container runs in privilege mode, the entire isolation mechanism is being removed. You can basically say that having a privileged container is equal to having application with root privileges. You can also see the command line that you can use to create a privileged container. In Kubernetes, we also using the security context field. You just need to set the privilege flag to true, and you've got yourself a new Kubernetes privileged container.
So you probably wonder to yourself how to discover those capabilities. So container capabilities can be viewed by reading the content of the main container process, which is usually represented as PID1. You can see the effective capability set highlighted in yellow. The capability displayed as bitmask, and each bit in the bitmask represents different capability. So here you can see a snippet from capability header on Linux source code. You can see that CAPSYS module is responsible for inserting and removing kernel modules, and CAPSYS pitrace can allow us pitrace to another process. And this is how we can decode it. So the most popular tool to discover and debug capabilities is CapSH. It is not available by default. It needs to be installed on the machine. Using CapSH tool, we can decode the bitmask. So we can install inside the container the CapSH tool, run CapSH print, and we will receive the available capabilities in clear text. But this is not a good practice because smart attacker will never do such a thing. So we can copy the bitmask to our local machine and the attacker machine and decode it using CapSH decode command and receive the available capabilities in clear text.
Cool. So now we've got to the most interesting part of our presentation, the use cases. We are about to show you a couple of demos that will demonstrate how we can take a simple process capability and abuse it to break out from the isolated container. Our starting point in each of the scenarios will be with a remote code execution inside of the container. Like we mentioned earlier, there are several ways for hackers to break into the container. We are not going to focus on this phase of the attack in this presentation. We will starting, like I said, already with an RCE inside of the container. So let's see the first demo. Our first demo is going to focus the CAPSYS module capability. CAPSYS module is the capability that in charge of loading and unloading kernel modules in the system. To perform this action, it uses the init module and the lit module syscalls. Our minimum requirements for this attack is having either of privileged container or having a container with the CAPSYS module effective on it. To perform the attack, we will going to install a new kernel module, and to do this action, we will need to execute the init module syscall. So you have to make sure that you don't have any up armor or other policy that will prevent this syscall from being executed. Here you can see the command line that you can use to start a new container with the CAPSYS module effective on it. So let me describe the attack flow that you are about to see. We will start, like I said, with an RCE inside of a container where we are going to compile a new kernel module that will share the source code in a minute. In the kernel module, we are going to use a function that named call user mod helper function. This function allows user to execute command lines in the user space area. And it also gets as an argument the command line that we want to execute. We are going to use a simple bash command line to create a reverse shell from the container to the attacker. Because it's a kernel module and it's being executed directly from the kernel, the reverse shell will start automatically with root privileges. Here's the source code of the reverse shell. You can see here the simple bash command line and the call user mod helper function. Now let's see the video. Cool. So the attacker starts a listener on his Kali machine. And now inside of the container, the attacker reads the main process container status, usually is going to be PID1, to see which capabilities are effective. Now we are copying the capFF bitmask to get the list of the entire capabilities that are effective in our container. We are decode the bitmask using capsh decode. And here's the list. We can see that capsys module is effective, which means that we're able to install kernel modules and means that we can continue with our attack. Now let's see the source code of the kernel module that we are about to compile. Here you can see the bash command line for the reverse shell with the attacker IP address and port and the call user mod helper function. Now we are going to compile this kernel module using make command. Before doing this action, you have to make sure that you have the matching kernel headers. Now we just need to install the kernel module. So we are using the insmode command. And at this point, you can see that a new reverse shell was being created on the Kali machine. You can also see that we have root privileges and that we are located on the host, which means that we successfully break out from the container.
Thank you, Eran. In this demo, we're going to demonstrate how to escape from a container by abusing the capsys ptrace capability. The capsys ptrace capability is very interesting because it gives us the ability to transfer data between processes by executing process VM readv and process VM writev system calls. In addition, it allows us to trace arbitrary processes using ptrace. So ptrace is a system call that allows a process to monitor and control the execution of another process and debug it. So in order to carry out such an attack, we will assume that we already have an access to the container or possibility to perform remote code execution. So let's discuss the minimal requirements to pull off this kind of attack. Firstly, the container must be started with the option PID equals host flag. This turns on the sharing between container and the host operation system with the PID address space. Then we need to start the container with either privilege flag or capsys ptrace capability. It is important to know that different container runtimes apply different up armor policies, and to perform this attack, we need to verify that the policy allows us to execute ptrace system call. So here is the command line we use to spin up this vulnerable container. We can see the security option up armor unconfined. That means that no up armor profile is applied. We added capsys ptrace capability and PID equals host, which allows us the sharing of the memory space. So this is the attack flow we are going to perform in this attack. We will use GDB, which is a Linux debugger, which allows us to see what is going on inside of another program while it executes. GDB is going to attach to the host process, which is running with root privileges, and it will try to execute a simple bash reverse shell from it. As a result, it will spawn a bash reverse shell as child process with the same privileges as the parent process. That means we will run with root privileges on the host machine outside of the container. So let's start a listener on the attacker machine. Now we will list the available capabilities inside of the container. We'll copy the effective capability, we will decode them, and then we will see that CAPSYS ptrace capability is available inside of the container. Now we are going to list the processes because we're sharing the same address space with the host machine. We can see processes running on the host machine. We see gedit running with root privileges. We'll copy its PID. We'll attach GDB to this process. And now we can debug it. We can run whatever we want inside of this process. And for this demo, we're going to execute simple bash reverse shell inside this gedit process. Because it's running with root, shell process will be with root either. So at this point, we receive the reverse shell to the attacker. We're running on the host machine with root privileges. And we successfully escape from the container. So you probably wondered to yourself, can this happen in real life? So the answer is yes. We crawled GitHub and we looked for a project that asks you to spin up containers with these vulnerable setups. So the first example is NordVPN. If you want to run NordVPN in containerized mode, they ask you to run it with CAPSYS module capability. As you saw in Eran's demo, we can easily escape from this container. Here is another example of a container running with privileged flag, a Kubernetes pod running with privileged flag, and in this example we can see Apache HTTP server running with privileged flag. That means that if someone receives a web shell inside of this server, it can easily escape from this container to the host machine. So during our research on machine learning script classifiers, we encountered an interesting script that targeted one of our clients. This is an automated container escape script. They use the same method as we showed you before. It is looking for CAPSYS admin capability to perform automated container escape after it. So you may think that your container is completely secured, but something small as CAPSYS admin capability can make your container completely vulnerable.
So the most known threat group that is related to the container attacks is named Team TNT. Team TNT active since October 19, almost 4 years ago. Their main specialty is taking advantage of containerized environment to deploy their crypto miners attack. So here's an example of threat alert that taken from Twitter that describes a new Team TNT Kubernetes malware. Another blog by Aqua Security about new Team TNT malware that attacks cloud environments. And another blog by Unit 42 Palo Alto about new crypto hijacking malware that targets Kubernetes. The thing that's common to each of these threat alerts that in all of them, Team TNT using similar methods to the attacks that we showed you earlier. So we want you to understand that those attacks are really happened in real life, and security experts must be familiar with those. So probably you wonder why Team TNT and other hackers want so badly target Kubernetes environments. So Kubernetes environments are considered as environments that have access to massive amount of data. Usually databases and web applications are stored in those environments. Also, Kubernetes nodes are considered as very powerful objects, which is good for the crypto mining activities of the attackers. Also, there are lack of security products that can monitor the Kubernetes node itself, and in general, it's very cumbersome to manage Kubernetes environments in security aspects. So Hackers can benefit from all of the above to execute malicious operations in Kubernetes environments without almost any interruption of the defenders. So now let's talk about detection and see how we can detect those cool and amazing attacks that we just showed you. So during our research, we were collaborating with the MITRE organization. We shared with them our inputs on the escape to host technique, and they liked our input and made us as an official contributors to the escape to host technique. So we can also look for all our findings in the MITRE official website. So our first suggestion for detection is try to monitor the deployment of every new container image or pod in your environment, especially the one who runs with root privileges. You can also try to monitor of suspicious execution of system calls that being executed inside of the container. You saw earlier how a simple execution of init module led to entire scenario of container escape. Our last suggestion for detection is try to hunt for process activity, especially process that can be an indicator of attacker that try to break out from the isolated container to the host machine. So now let's talk about mitigation and see how we can minimize the risk to be affected by those attacks. So our first and most important recommendation is when you are creating a new container, first drop the entire capabilities, and only after that, add the relevant capabilities that matches the purpose of your container. We also recommend to minimize as much as possible the usage of privileged container and try to avoid the capsys-admin capability. You can also use policies like AppArmor that can prevent capabilities per specific programs. Kubernetes has policies that can prevent the creation of containers per specific capabilities. And of course, you can use the second filter for blocking specific syscalls per capabilities.
So I want to focus a little bit about the second BPF because we think this is a good mitigation for these attacks. So what is the second BPF? Firstly, it is a JSON formatted structure security profile which is implemented with the BPF technology. BPF allows us in-kernel selection of packets, and then, therefore we can drop a selection of system calls. It can be considered as system call firewall because some capabilities allow the system calls will be executed and the unpermitted will be denied. So, so if a system call will fail, the program will continue running. Docker runtimes allow us to set second BPF filter to container by default. So this is a given feature. You don't have to install anything. So this is how second profile looks like. It is very similar to how firewall policies looks like. We have three available actions. We have second action allow, which allows system calls. We have second action error no, which denies system call, and second action log, which logs down permitted system calls. On the left, we can see the second profile JSON. We can see the default action is second action error no, which means all actions will be by default will be denied. And we have a list of allowed system calls with the action second allow. The default second profile blocks 44 system calls out of more than 300. That means we need to harden our containers. And to apply second profile to a container with Docker runtime, we just need to add a security option flag with the second profile JSON as an argument. So let's conclude this talk. So capability controlled invocation of system calls. As we saw, some system calls are directly associated with capabilities. All capabilities combined together will be considered as root privilege. Some of those system calls can lead to a container escape, as we saw in the demonstration. We have to be aware of the capabilities that assign to our container. We need to use the mitigation process that we showed you before. And we should try to mitigate as much as possible the use of unnecessary capabilities. As Aran mentioned before, we need to drop all the capabilities and add only the relevant ones. Thank you. We hope you enjoyed our talk.
Okay, thank you very much. Do we have any questions from the audience? Just raise your hand, don't be shy. Okay, then I'll start with the question. How common do you think the misconception is that, like, as your slide shows, the difference between a VM and a container? I mean, to me, it seems there is a lot of confusion in the general public. Do you also see this when you come out to clients, etc.?
Can you repeat it?
So, do you think it's a general misconception, the security boundaries and the difference between a proper VM or a virtualized host and a container?
Yeah, actually, we think that a lot of people that don't familiar with the container, with container internals, are thinking that containers and VM and virtual machine are basically the same, and it's actually very wrong. And you need to give every one of them different attention.
Yeah. Any more questions from the audience? There we have one.
Thank you for a great presentation. How about the rootless Docker? You have versionless Podman as well.
Couldn't hear, sorry. Can you repeat?
How about rootless Docker? You can run being root inside a container, and
you can escape. You can escape from the container if you are root just inside. If you don't have the certain capabilities. Yeah.
Okay. Thank you.
Hey, thank you for a great talk. I have a question with something I've struggled a lot with while building these security contexts and limiting and restricting capabilities. Have you ever discovered any automated tools to identify which capabilities a container image might need, like a profiling tool? And if not, how would you go about discovering them without threading through all the source code? Ptrace?
Sorry, just hard to hear, I'm sorry.
How would you go about discovering all the capabilities that a container image might need without going through all the source code manually?
If I understand your question right, you want how to discover the capabilities that we need to add to our container. Okay, so our containerized app, you can use strace, for example, in Linux, and you can see all the system calls that are executed. All right, and you can automate it using like a dictionary or something that certain capabilities and the associated system calls.
Okay, thank you.
Yeah.
I have a question. You had examples capability admin and ptrace where you can escape the container. Are there many more capabilities that you can use for escaping as well, or are those the only two that you have identified?
No, there are many more. There are many more. We just introduced you two. But there are net admin and there are much more.
No.
Okay, I think that's it. Thank you very much for your presentation. And yeah, a big round of applause.
Thank you.
Thank you.
Okay, so be back for the next talk, 3:45, 3:45 for the next talk. Thank you very much. I think we have power again, guys. Big round of applause. Power is back. Yeah, this is the first time this has happened, but there is always something that's going to go wrong. So luckily it wasn't worse. So yeah, I was going to say some very smart and interesting things, but thank you for waiting for this. And welcome up Joris. And we hope that the presentation screens are coming online as well. Okay, the presentation screens will come up in 2 minutes, so I'll take the time. No, you can stay on stage. You can stay on stage, don't worry. So this talk won't let's do a 5-minute break then when we find the next speaker. So we're just going to have a quick 5-minute technical break and see you back here soon.
Kan du kolla att den botar? Vänta.
Okay.
Ja, vi kan kolla.
Everyone, it's time to make your way back for the final talk of the day.
Ja, ska bara.
So, and we are a bit not too much behind schedule, but this is the final talk of the day. The bar is still going to be open. You can still mingle, but this is the last.
Så bra ut. Ska vi kolla filen lite?
So, without further ado, if you guys are ready.
No!
They're not ready.
1 minute.
They need 1 more minute.
Yes, please.
To do this.
Go away.
What else? We are going to have a speaker dinner tonight. So if you're a speaker, like including you guys, when you're done, the speaker dinner is upstairs, up the stairs in the entrance. So it's at 6 o'clock. Okay, now we have something happening on screen here. So this looks promising.
We are almost ready. There we go.
Okay, take it away. Good, Eric and Eric from With Secure.
All right, hello everyone.
Welcome to this talk titled Domain Admin Through Breaking and Entering. My name is Eric Alm. I am a senior security consultant at WithSecure. I mainly work with red teaming. So when I say that, that means essentially simulating targeted attacks towards our clients using covert operations the same way a real threat actor would. Now, fortunately for me, this sometimes entails physical security as well. So in case you were wondering who the tired-looking guy with a coffee is, it's not just my morning routine. This is actually a selfie that I took after being lovingly handed a coffee by the receptionist of the main office of one of our clients, where I was visiting a person that no longer actually works there.
My name is Erik. I too work as a security consultant at WithSecure. I mainly do application security and penetration testing, but have found my true calling in bullshitting my way into places where I don't belong. So I've been doing a lot of that these last couple of years as well. My picture here is me and a colleague of ours brute forcing our way through a RFID badge reader at a client engagement. So we're going to talk a bit about physical security testing today. We're going to have a little show and tell from some of our recent engagements. The demo gods willing, we have a small practical demonstration where we're going to attempt to do a card cloning as well. It's going to be fun. So yeah, that's it. As cybersecurity professionals, why would we care about physical security, right? Well, besides the obvious, sort of compliance question where cyber and physical security controls kind of intertwine because you have them, in your ISOs and SOC 2s and what have you. There is a strict interdependency between them, where if you have a threat model where you have a physically capable adversary, having or lacking physical security controls will severely undermine your cybersecurity controls, right? You can have the most advanced EDR or XDR or whatever DR system in the world, but if you allow anyone from the street to just go in and plug in an unmanaged device on your network, all of that visibility goes out the window anyway.
And so just to clarify that this isn't just an excuse for two guys named Eric to, role play James Bond and get to do really cool super secret agent bullshit. These are some obviously cherry-picked examples of real threat actors leveraging, bypassing or breaking off physical security controls with the aim of achieving cyber-based objectives. All right, so when we actually talk to our clients about physical security, one of the things that we like to start with talking about is what we call their physical risk profile, right? And so what we mean when we say physical risk profile is basically answering the question, what should we be worried about, right? So that is going to be the enabler for that organization to spend their resources, effectively in places where it makes sense, right? So obviously there are different threat actors for different organizations, right? So if we look here at this beautiful graphic that I've made, the sort of base of the threat actor landscape when it comes to physical security is the opportunistic attackers, which is, people that just see something that's valuable and think, I like stuff that's valuable. So that could be, for example, walking past an IT room and just saying, oh, cool, laptops. Boom, window, dead, run away with laptops. Then we move up to this middle segment where we typically see organized crime. And that could be, for example, what I showed you on the previous slide, these threat actors that do the, almost at this point, stereotypical, hey, I'm here to deliver a package. And they get let in, but the real package they deliver is just like a Raspberry Pi they use to get initial access to the network, which is, sort of between the lines what me and Eric do. Then at the very top, and hopefully not every organization has to worry about this. This is, highly dependent on both your vertical and the size of your company, right? How big of a target you would be. But most likely, not everyone needs to worry about these advanced persistent threats. But that could be things such as, a state-backed industrial espionage campaign where they find an employee of a company and say, you want extra money? We'll give you extra money if you give us all of the secret shit from where you work. Or someone just saying, hey, I'm an IT admin. I see that you're looking for an IT admin. I take employment there and then do nasty shit as an IT admin. Right? So regardless of which of these threat actors you're sort of taking into account and like based on having evaluated your risk profile, it's pretty much always about reducing the window of opportunity. So for the example where it's just someone that lobs a rock through a window and runs out with all of your laptops, that reduction would be maybe in the form of putting bars behind your windows or not having windows at all in your IT room. And for the more like advanced attackers, that could be something like implementing a 4 eyes process so that nobody is allowed to be alone in the most sensitive areas, right? That significantly reduces the risk because you all of a sudden require 2 insiders.
So yeah, we're going to break things up with the practical demonstration to sort of get that out of the way quickly. We're going to go over a couple of different vulnerabilities that we usually find on these jobs, but for the practical demo, we're going to at least attempt to do a badge cloning, which is something that we usually do on most of our jobs because it's like 1,000% success rate.
And we like badges.
We're going to see if we can get this over the mic. We're going to see if we can Alt-tab to the ESP key interface.
Yeah, it worked. Nice. Step 1 complete.
Amazing. So what we usually do, for those who don't know, is that plenty of these access badges are using low-frequency RFID, which is essentially, a chip on the card which is powered by the actual badge reader, and it has a small, a couple of bytes identifier, often issued sequentially, so you can easily brute force them if you have like a lost guest pass or things like that. Nonetheless, what we have here as well is in our messenger bag a long-range RFID reader connected to a small chip that you can get online or sort of build yourself from cheap components. I believe this is the real deal, called an ESP key. And what this little thing does is that it takes all of the information from your badge reader. It talks this protocol called VGAND that most of these products are using, and it emits a small access point over Wi-Fi, so you can read everything that is actually being parsed by the reader. You can replay whichever badge identifiers, etc., or even pin codes that it sniffs off.
Yeah, so what we have here up on the screen right now is actually that laptop hooked up to a wireless access point that is inside of this bag. Would you mind trying to refresh the page to see if we successfully read it?
Is it going to work? I don't know. So usually what we do is we just make sure to stand close enough to someone, and this distance is it's kind of uncomfortable. I'm feeling kind of uncomfortable here. But if there are plenty of people in an elevator or in a crowded lunch cafeteria, it's kind of fine, right? You could even lift it up to pick your nose, or whatever. And like most of the time, it works every time.
Except when you try and demo it, right?
Oh, wait. There we go.
So actually, yes, it worked. Yay.
So can we... we can't click this. Yes, we can. Okay, so it snips off the identifier for the badge. We're able to replay it at will, so if we have this implanted somewhere, we can just repeat the reading or writing, etc.
Or you can write this UID to a badge that you just have laying around, and then you can badge in as if though you were the user that you actually just cloned. Let's see if we can get back to the presentation. Yes. All right, so just a little bit of a continuation here. As Eric just said, that what you can actually do with this little tool, apart from putting it into a regular long-range reader, is you can actually use these headers here. If you unscrew the reader, and a lot of these readers aren't securely mounted. I mean, this is a case where it was just regular screws, so you could just bring a screwdriver and unscrew it yourself. What you then do is you expose the wires, and you use this little tool and these terminals here. You basically split the wires and pass it through this little chip. And what you can then do, using this same interface that we just demoed, you can then replay attacks remotely since it's a wireless access point.
It picks up pin numbers as well if it's on a number pad, like we have pictured here. So sometimes these readers are connected with these security screws, like, and you need an actual key to open them up. Pictured here is your standard sort of Vanderbilt or Samsung or whichever brand they are these days, EM40 whatever. And if you look underneath them, you see this little box with a number in it. And I don't know how clean you can see it, but it says 26 on this one. And that is the key number. There are about 50 keys in circulation for these things, and you can get them for very cheap on eBay. And it's the same for everyone. So for any given organization, you usually need to find maybe 1 or 2 or 3 keys at most in order to start tampering with the readers. When you open them up, you're going to trigger a tamper switch that is going to send a small notification to a computer in the building that no one ever looks at. So just don't worry about that. Next up, networked printers. Usually these days, you can't just walk in somewhere and plug into any Ethernet port. People are using 802.1x or other such authentication measures to make sure that only specific ports that are in use are allowed to be on the network. Being hunched over a printer like this, or just jumping behind it and putting down your 4G enabled Raspberry or whatever with a small switch, it's super easy to just inject yourself into that authenticated data stream and just hit the network from that point. This picture I took on a client engagement earlier this year. It was a room where they housed the workstation that controlled the security system, and there were always employees in there. And when they weren't, things were locked down using this combination lock. And where the process failed was that every time they locked the padlock, they actually scrambled the combination, but they didn't scramble it any time when they unlocked it. So whenever people were there and they felt safe and they were always watching this workstation, you could just go in and take a quick peek at the combination and just show up later. And you would be able to get full access to the rest of the building. And the classic, of course, if you have the most secure lock, you can have biometrics and everything on the super secure door. If you don't make sure that your walls actually go all the way up to the ceiling, we're going to just jump over it. And this is why we bring a ladder on all of our engagements, because this is common. And my favorite, this picture got sent to us from a colleague on an earlier engagement where they were infiltrating this compound, super secure. You can see there's a fence, they have cameras all over the place and so on. And they found this lockbox out in the public parking space, which they managed to pry open. And inside they see a switch that gave them access to this security VLAN that controlled the cameras and so on. So after a very rudimentary port scan, they found the management console for their physical security controls, which of course had default credentials still on it. So before even walking in the door, they had full permissions on their own access badges. They could see all the cameras everywhere, and they could just walk in as they saw fit. And lastly, the most common thing, right? Nobody cares about what you're doing, as long as you just act like you belong. I mean, this is a trope, and everyone keeps saying this. And every time you're on a job, you're super nervous about it the first time. But really, nobody cares about who you are or what you're doing. So as long as you look busy while doing it, you can get away with whatever.
Yeah. So enough of us just talking about these theoretical things that we may or may not see. We obviously came here to brag about the cool shit that we've done. Small disclaimer, client's gonna client, so to protect us from ending up in a physical security nightmare, aka jail, we're gonna have to redact some details, but hopefully it's still gonna be entertaining.
Right, so to give you an outline of one of these engagements that we have been on, this was a global corporation with a couple of locations in Stockholm. And they approached us to test their resilience against corporate espionage, which is a ton of fun, because usually on these things, your objective is to get in somewhere, leave a business card, or plug in and ping a machine on the client's network. Here, our objectives was to plant fake surveillance equipment in the offices of their executive, like C-suite, upper management, as well as photograph their financial statements, upcoming product prototypes, and things like this. So methodology-wise, the way we structure these things are usually the same as any cyber job. We start off with a reconnaissance phase where we just kind of sleuth the internet. We bring down blueprints from the city planner's office, at least in Sweden, which is fantastic. Protocols from renovations or whatever that is going on. And we start thinking about initial access, which is usually things like card cloning or just tailgating and social engineering and so on. So for this, the first objective was hitting the finance department, where we knew from the recon phase that they were renovating the floor below. So I showed up one day in workwear, going, "Hey, I work downstairs. I'm sorry, but we fucked up the sprinkler system, and there's no pressure at all. I'm going floor to floor to just make sure that we didn't cause a fire hazard for you guys. Do you mind if I just, real quick?" And she was like, yeah, of course, that sounds super important. Come on in. So that got me into the finance department, where they had this open floor plan, but everyone was out to lunch at the time. And I surely didn't look like I belonged, because I was just grinding binders blindly in order to take my pictures, sweating bullets, shaking. But luckily for me, no one actually showed up. So at this point, we had the surveillance equipment objective still ahead of us, right? So after a couple of weeks of walking around in the office or offices and getting a lay of the land and sort of thinking about this, we realized that the executive floor, which was kind of reserved for only those with executive upper management badges, they had this passive infrared sensors on the inside. So you didn't have to beep yourself when exiting, only when entering the floor. And for those who don't know, these passive infrared sensors have a very common vulnerability, because the way these things work is that they measure changes in temperature. They don't measure necessarily body heat when you approach them. So if you just go to your IT department and grab a regular can of air duster, that you use to clean keyboards and whatnot, and you hold it upside down, then the cold compressed propellant gases are going to exit instead of the regular air. So if you manage to spray that through or beneath the door, you're going to have it magically open, because it's going to trigger on the change in temperature, right? Demonstrated on the video here at this particular client. And this is while plenty of employees are watching, by the way. Nobody cares. I guess they thought I was cleaning the door or something. Because that got us into the offices and meeting rooms of upper management, where we could just place our various equipment. The final objective being taking pictures of the product prototypes. We just went outside the lab, found the closest employee, and say, "Hey, do you know who can open this door for us?" And they went, "Yeah, well, I can. Do you need me to?" "Yes, please." And they did. And never mind the big sign on the door saying "No unauthorized personnel." They were like, "Yeah, we're just going to fix something in the ceiling," and mounted a fake ceiling camera, and got out of there. So by the end of all this, the chief of security, our actual client, went, "Hey, we need something more impactful than this to sort of raise awareness and see. So we want to see you get caught with something." So he went, "You know what, go back to the executive floor, break in with the air duster or whatever, and just clean it out on as many office chairs as you can, through the main entrance and not through the operations staff exit." So we got about 20 of them out before we started getting tired, and we called them up and like, "Is this fine?" And I said, "Yeah, whatever." And at this point, the security guard that was watching us take all of these things out, he actually approached us and went, "Hey, what are you doing?" And I went, "Well, we're replacing all of these chairs, but it looks like our ride isn't coming with the replacements. Can you help us bring them back up?" And he was like, yeah, sure, of course. And we started dragging them together. And I still feel kind of bad about this, because he came to me afterwards and went, "Hey, can I get a replacement chair as well?" And I'm like, "You bet, man. I'll write that down for you." That was kind of the end of it.
Yeah. So with that, I'm going to be telling you about a little bit of a story from earlier this year. I have informally dubbed this Eric's Winter Adventure since it took place in January in cold, gray, snowy Netherlands, right? So this particular assignment was for a global logistics company headquartered in the Netherlands. The project itself was a covert red team with, the end goal being compromising business critical systems and functions, right? But the interesting part of this assignment was that it contained physical objectives as well. So in order to actually obtain those cyber-based objectives, the entry point for that was physical. So part of these physical objectives of the project was to actually just get into like restricted areas. I don't know why I did that. Maybe that's a spoiler. But the restricted areas, also to then install a network implant so that we could access the network that way. More of like an optional objective was to see if we could break out of their kiosk systems that they had in the lobby and use those for something. And just quick reminder here, a kiosk system is like a semi-public computer that is like running a boxed off application that's intended to only allow the user to do one thing. But if you're a, computer guy, you're going to find a way to make that do something else, right? So with that, me and two colleagues flew to the Netherlands, stayed at a not great hotel close to the office. And as Eric mentioned earlier, the standard methodology applies. So we start with just reconnaissance, basically walking around the building looking as normal as possible as you can while you're walking around in January in the Netherlands around just a boring office building, right? But nobody found that suspicious, and we found all of this information that we need, such as, employee movement patterns, dress codes, where people come and go, how people come and go, etc. Right? So pretty quickly we realized, all right, cool, we could probably just walk right in. So that is being under the condition that somebody holds the door for us, right? Which, in case you don't know yourselves, look around you, everyone's going to hold the door open to everyone in this room because nobody here looks really that kind of weird or dangerous. That fortunately includes myself and my team, so we just waltzed right in. Hunched under someone's desk and throw back to the printer image that Eric showed earlier. Doesn't matter if you have network access control like 802.1x, it's possible to just bridge that connection and piggyback off of an authenticated laptop. So this is my beautiful Raspberry Pi-based implant. But, we decided, hey, come on, we don't want to risk the client here thinking that there was just some super polite weirdo that just held the door open. So, this little bad boy came out, the guy we just showed you. We nabbed some credentials, and all of a sudden we had our own access card, so we could come and go as we pleased, right? So we spent some time just, hanging out in there. All the while I went down to the lobby and continued mucking around with these kiosk systems, and lo and behold, I don't know if anyone here has touched one of those, but click one place you're not supposed to, boom, you're friggin' out of there, Unfortunately, I don't have any useful picture of me installing Cobalt Strike on those kiosks. You'll just have to take my word for it. Instead, here's a picture of me enjoying a massage in their recreation room where I could also just walk right in.
Right, so what can we learn from this? We usually give recommendations that are highly specific for any given client, so it's hard to give a one-size-fits-all recommendation. But determining this initial risk profile or threat model is a decent first step to sort of figure out what you're up against, what you think you're up against, and from there you can start conducting a gap analysis against what you currently have in order to identify weak spots in your system. By implement a robust access control system, we're talking about batch readers and so on, that this is technology that doesn't move very fast, right? These are archaic protocols. most of these systems have known vulnerabilities, and you need to either accept those risks or take them into account some other way. And finally, knowing and managing your assets, and these are everything from servers and access control to them, but also of course your employees. Where if you have a culture where people just don't care, or there's no way for them to be empowered enough to report suspicious activity without having to be confrontational themselves, you're going to lose out on a lot of visibility.
Right, so final slide of the talk. I know everyone's eager to go get smashed on beers, but just some key conclusions and takeaways that we want everyone to walk out of here with. The first one being that whether you like it or not, cyber and physical controls actually work in unison. So what I mean by that is you could be physically you could be Fort Knox, but if the admin panel of one of your most important systems is out on the internet, you're kind of dead, right? Conversely, if you have all of the cyber bells and whistles, but anyone named Eric can just walk in from the street and plug themselves in and evade all of your fancy BS, you're also kind of cucked. The second point being that perimeter defense is not everything, and this is fortunately something that most people have accepted as the truth in the cyber world, but the same is true for physical security controls as well. You need to take an approach where you have compensating controls. So instead of it being a case where once you walk past the reception, you're in, you could do anything, strive to maybe lock up your secret documents, maybe put a lock and scramble the combination on whatever thing you're trying to defend, right? Finally, probably the most important thing, and hopefully something that you all already know, but it's worth repeating regardless, it's always best to test your own security yourself before someone else tests it. Thank you.
Thank you very much.
Thank you very much, guys. So yeah, it helps being named Eric, maybe, I don't know. Any questions from the audience before we break up for the day? I have one all the way over there.
You told us a lot of stories about how you got away with it. Do you have any story of how you got caught?
Yes, actually, I have one. So I used the trick where I checked in to visit someone that no longer worked there. Turned out there were 2 people with that name. So I had continuously been notifying this person that does actually work there. They got really suspicious after a while. And so when I had gotten access to the building and I had done my stuff, actually the receptionist came back and he was like, what the fuck? Basically, the way that I handled that was by saying, there's been some mistake. He didn't buy it. And I did the very, very brave move of sliding a piece of paper across the table saying, I'm allowed to do this, trust me, bro. And he did. Just escorted me out, didn't report anything, so chef's kiss.
Another question here.
The RFID attack that you did, is that based on MyFair Classic or EM or?
So these particular cards or tags are EM 1100 or what it's called. But I mean, it also works against some of the crappier MyFair standards that have a small key space or commonly used keys that you can just sort of trivially brute force your way through in a short time window. It takes if you're lucky, it takes half a second. If you're unlucky, it takes maybe a minute. So, yeah.
That keypad attack, is that valid on other platforms as well?
What do you mean by platforms?
Yeah, the keypad, the readers,
Everything speaking the weekend protocol at least.
The what?
The weekend protocol is the physical binary protocol that the reader speaks to the control unit.
Yeah, to the backend controller. So what we've found is the majority of card readers still rely on the weekend technology or the weekend protocol. It's like a whole family of whatevers, but and that protocol is inherently vulnerable because it was designed 2 billion years ago. So. Anyone else?
Okay, then thank you very much.
Thank you very much.
Big round of applause.
Yo.
And that's it for this new community day. There's no more official programming. The bar will still be open. You still have a
Can I
drink.
ask a quick question? How many here don't have tickets for tomorrow?
Okay.
Awesome. Okay, so at least some people that got to enjoy some talks at least. I think there might be some recall tickets. We will see what happens. The second thing is all speakers and all business ticket holders should go upstairs at 6 o'clock for the speaker's dinner thing. So if you have a business ticket, or if you're a speaker, or if you're an organizer. Otherwise, I will see you all bright and early tomorrow. Yeah? So no late night tonight? Tomorrow's going to be crazy, though.
Okay, thank you very much. Thanks for coming.